Okay, 3.4, we are going to start with zeros of polynomials. So we're going to start with graphing. We're just going to do some activating some prior knowledge here. So let's graph this graph just in our graphing calculator is fine. So if I come over to y equals here, I'm going to put in x cubed minus 5x squared plus 2x plus 8. And then hit graph. Okay, I got a nice cubic function here. Looks like I am crossing the x-axis at -1, 2, and 4. Got a y-intercept of 8 there. Okay, I can check that on my table, so second table. We can look at these points. So yeah, I've got a point of 0, 8. I'm looking here at these points. All right, so I've got a -1, 0, 0, 8, 1, 6, 2, 0, 3, -4. So I can start plotting these points. Okay, so let's plot these points. Let me make this just a little bit thicker so we can see this. Okay, so we've got a -1, 0, and we had -2, -24, so that's pretty bad. 1, 2, 3, 4, 5, 6, 7, 8. So 0, 8. Then you have 1, 6. Then you have 2, 0. You've got 3, -4. And 4, 0. Let's see what 5 was. 5, positive 18. That's going to go off the graph. All right, so if we try and do this, it's going to be a little messy because it's hard to do this on my little notepad here. But we're coming up from way down here. Whoop, that was really bad. Maybe if I go this way. All right, I'm coming up from down there. I'm going to go up here to this y-intercept, turn. Got to go down here and turn and go back up. That's pretty bad. It's really hard to draw in a straight, steady line with this thing, but similar. You know, looks like a toddler drew it, but there's the exact graph right there. All right, so x-intercepts. Okay, that's what we're interested in here. So the x-intercepts of this function we see are -1, 2, and 4. All right, so we've identified the x-intercepts. Well, now we're going to do an exercise where we find the indicated values. Okay, so we find f of 2. So let's see, f of 2 will be 2 cubed minus 5 times 2 squared plus 2 times 2 plus 8. Well, 2 cubed is 8 minus 5 times 4 is 20 plus 4 plus 8. Let's see what that is. 8 minus 20 plus 4 plus 8. 0. So f of 2 is 0. Okay, let's do that with -1. -1 cubed minus 5 times -1 squared plus 2 times -1 plus 8. -1 cubed, -1. This is going to be +1, so minus 5. 2 times -1, minus 2, plus 8. -1, minus 5, minus 2, plus 8, 0. Then we'll do it with 4. We've got 4 cubed minus 5 times 4 squared plus 2 times 4 plus 8. So 4 cubed, 64, minus 5 times 16, I think it's 80. Plus 8, plus 8. So 64 minus 80 plus 8 plus 8, 0. So the x-intercepts, if I plug them into the function, I get 0 every time. Okay, because it's giving me a point, 2, 0, -1, 0, 4, 0. It's giving me the x-intercepts. Okay, now What if I take these numbers and put them into functions as x minus c? So x minus 4, x minus -1, and x minus 2, and I multiply them. So let's do x minus 4 times x plus 1. So that's going to give us x squared plus 1x minus 4x minus 4, x squared minus 3x minus 4, and then multiply by x minus 2. So x times x squared, x cubed, x times -3x, -3, x squared, x times -4, -4x, then -2 times x squared, -2x squared, -2 times -3x will give us a positive 6x, -2 times -4, positive 8. Add these together, what do I get? X cubed minus 5x squared plus 2x plus 8, which happens to be the function we started with. All right, so the whole point of this is to show you guys what? What can we infer here? If I factor this problem, what am I getting? I'm getting this, right? If I solve this and I plug those into the problem, I'm getting 0, which are giving me the intercepts. So the zeros are your factors, are your x-intercepts. Those are your solutions to your polynomials. So they are all related. So if you look at the graph and you see your x-intercepts, you solve your polynomial. Okay, if they say solve this polynomial, you put it equal to 0, graph it. You can see all your x-intercepts. Those are the answers. Some of the x-intercepts, though, you can't quite see. They're not whole numbers. Okay, or sometimes they're imaginary. They have an I in it. Okay, so we have a process for finding all of these zeros. So these ones all happen to be very nice, neat, whole numbers, but sometimes they're not. Okay, but we are going to have at least typically one whole number solution, unless it's a quadratic. In that case, quadratics can sometimes just be imaginary. All right, so here is the process for finding the zeros of a function. So we're going to start with this function here, -x to the 4th plus 3x squared plus 4. So we're going to start by using our graphing calculator. If you do not have a graphing calculator, there's a process to go through with plugging values in, which we'll look at just after this. Okay, so if you don't have a graphing calculator, it's still doable, but this is where it gets to be a huge pain if we don't have a graphing calculator. Okay, so it takes much longer. So graph this. So y equals -x to the 4th plus 3x squared plus 4. And then we'll graph it. All right, so kind of looks like McDonald's arch here. Our two zeros look like they are -2, +2. Check the table. Okay, so you've got a 2, should have a y value of 0. And you have a -2 with a y value of 0. Okay, so if the y value is 0, those are your x-intercepts. So you have two x-intercepts, -2 and 2. And we can draw a rough sketch of what this graph looks like. We're going through the graph here. 1, 2, 3, 4. 1, 2. So McDonald's, something like that. All right, sketching the graph. There are 2 more zeros in the function. How do I know that? Anybody know how I know that? And those are your 2 zeros. Where are the other 2 zeros? We got to find them. But how do I know that there's 2 more? Look at what I circled. Yeah, because it's a 4th degree. So quadratic has 2 zeros because it's squared. And then cubic function has 3 zeros because it's cubed. 4th degree function, you're going to have 4 zeros. Sometimes they repeat. Okay, they have a multiplicity, but that's how many zeros you're going to have every time. So the degree is going to be the number of zeros. So I've got 2 of them. I've got -2 and 2. The other ones I've got to find. So this one, I can actually just factor this. Okay, so for this one, I can, let's see, set the equation equal to 0 and factor. I want to factor this. I want to change the sign, so I'm going to pull a -1 out of here and make that a positive x to the 4th minus 3x squared minus 4. And then I'm going to factor that. But when I factor it, I'm splitting the middle term as x squared and x squared. So then I say what multiplies to -4 adds to -3. Should be a negative and a positive. So -4, +1, -4 plus 1, -3, -4 times 1, -4. Then take each factor, set it equal to 1 or 0. So you get x squared minus 4. That gives you an x squared equals 4. And that's where that plus and minus 2 come from, square root of 4. Then your other zeros, x squared plus 1, set that equal to 0. That gives you x squared equals -1. Then take the square root of -1. What's the square root of -1? I, yeah, I. I knew you meant that, you just said. Yeah. Plus or minus I. So those are the other 2 zeros. That's why I'm only crossing the graph 2 times, but I know there's 2 more zeros because of the degree. So my 4 zeros are +2, -2, positive I, negative I. Now, how would I check that? I'm not going to do it, but I'm going to show you how you check it. You make them into the factors. So if I wanted to check this, I would just go x minus 2 times x minus -2, so x plus 2, times x minus I, times x minus -I, so x plus I. So I've got to multiply all that out. That should get me back to the function. Okay, so what if I don't have a graphing calculator and I can't get the first 2 zeros on my own? You're going to use the rational zero theorem, which just tells you all of the possible rational zeros of a function. Okay, so what you're going to do is you're going to take the constant over the leading coefficient, all of the factors. So you're going to factor them. So it's P over Q, where P is all of the factors of the constant, and Q is all of the factors of the leading coefficient. So P, Q. Okay, so for example 1, all of the factors of P. So everything that would multiply to 4, and you're ignoring the signs here, so it's going to go like this. What multiplies to 4? You've got 1, so you go plus minus 1, and 4, and 2. So plus minus 1, plus minus 2, plus minus 4. That's everything that could multiply to 4. Over all the factors of 3. Only thing that multiplies to 3 are 1 and 3. So plus minus 1, plus minus 3. And then you break it out one by one. So you would go 1 over 1 gives you 1. So that's the first possible 0. Then 1 over 3, 1/3, plus minus 1/3. Then 2 over 1 gives you 2, so plus minus 2. Then 2 over 3 gives you 2/3. Oops. So plus minus 2/3. Then 4 over 1 gives you 4, plus minus 4. And then 4 over 3 gives you 4/3. So those are all the possible rational zeros. So if I am starting a problem where I'm trying to find the zeros and I don't have a graphing calculator, I'm going to start with positive 1. I'm going to plug it in, see what I get. If I get 0, I got lucky. If I don't get 0, then I go on to negative 1. Then I keep going until I find one that I get 0 with. So see how it's easier to have the graphing calculator? You still do it without it, but before they had them, this is what we had to do. I say we. They had graphing calculators when I was in school, so people older than me. All right, example 2. So when you have a leading coefficient of 1, it's just p, because the only thing that multiplies to 1 is 1. So then this would just be plus minus 1, plus minus 2, plus minus 4. Okay, but if there is a number in front of your leading coefficient, then p over q. All right, so let's walk through a longer one here. All right, so I have here on the example that we're going to go through a process where we list the possible rational zeros, because on some of the homework problems, you're going to have a couple different steps where you have to do that for them. So we'll start with that. So you've got a constant of 12, a leading coefficient of 1, so it's just factors of 12. So everything, that's a lot actually. So everything that multiplies to 12, you've got 1, 2 goes in, 3, 4, 6, and 12. I think that's it. 1 times 12, 2 times 6, 3 times 4. Okay, so 1, 2, or 3 of these are going to be zeros of the function. How many zeros are there going to be of this function? 3. Yeah, 3 solutions, because we're a cubic function. Let's see if we can find one of them in my graphing calculator. So I'm going to graph this. I've got x cubed minus 10x minus 12. All right, so it looks like negative 2. And then this doesn't look, it looks like it's between 3 and 4. So probably some sort of decimal here. Go to your table, check it. There is a 0 at negative 2. I got one of them. Okay, so one of the zeros is negative 2. And I turned right there, and also 1, 2, 3, 4. There was something in between here. And so it went like something like this. No, it didn't look like that, did it? Second graph. We'll go to the table. Go to hit zoom 6 when you have a window error. Okay, so quit. And then go zoom 6. And then go to window. Did that work? What? Mm-hmm. Did you get, who else had the error? Did you get yours? Okay, let me come take a look real quick. Okay, so we have established that negative 2 is a 0 of the function. So what we're going to do is we're going to divide out the negative 2 using synthetic division. So we have negative 2. We're going to divide into this function, which basically means that we're reducing it from an x cubed to an x squared function. Now this is missing an x squared, so I want to make sure I write this out. Okay, x cubed plus 0x squared minus 10x to the first minus 12. So make sure I'm not missing any x's there. So then I would have a 1, 0, negative 10, negative 12 as my coefficients. So I bring down the 1. Then I do 1 times negative 2, negative 2. 0 minus 2, negative 2. Negative 2 times negative 2, positive 4. Negative 10 plus 4, negative 6. Negative 6 times negative 2, positive 12. I want to make sure this is 0, meaning I got the correct, one of the correct zeros of the function. So now this reduces this to the equation x squared minus 2x minus 6. So the goal here, what you're doing is you're going to find a 0, you're going to divide it out and reduce the function 1 degree down. And you're going to keep doing that until you get to a quadratic function, at which point you can factor. You can, if you can't factor, you can use the quadratic formula and then solve. Okay, so this one, you only had to reduce it once. If it's an x to the 4th, you would reduce it twice. If it was an x to the 5th, you'd have to do it 3 times with the zeros. Okay, so here, we're going to use a quadratic formula to find the other 2 roots, since it doesn't factor. So set that equal to 0. And then, just in case we forget, I'll write it on the graph. Negative b plus or minus the square root b squared minus 4ac over 2a. So let's see. Negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 6 all over 2 times 1. So the negative here becomes plus. Then let's see, negative 2 squared is positive 4 minus 4 times 1 times negative 6. That's negative 24. So that's going to become plus. So 28 under the radical. So let's see, we've got 2 plus or minus root 28 over 2. Is that going to simplify a little bit? Yeah, we can pull a 4 out of that. Radical 4, radical 7, and the square root of 4 is 2. So then this looks like this. 2 plus or minus 2 root 7 over 2. Can I take all those 2's and reduce? Yeah, so 1, 1, 1. So final answer here, 1 plus or minus 1 root 7 over 1. So I just need to write 1 plus or minus root 7. So my 3 solutions, so anytime you have to go down to quadratic formula, you're going to have either radical solutions or imaginary solutions. Those are going to come in pairs because of the plus or minus. So there will always be 2 of those. So you've got 3 solutions. You've got x equals negative 2, the first one we found, and then 1 plus root 7, 1 minus root 7. I don't care if you use the plus or minus sign. Sometimes they'll be written completely out. And then also, if you look at the graph, because you did actually have some points that you crossed, 1 plus root 7, that's that number between 3 and 4, where it went through the graph. 1 minus root 7, negative 1.6. So if I look at the graph, it does kind of touch at negative 2, and then again right here, kind of lingers there a little bit, and then there's that 3.6 going through the graph. So those are zeros, they're just not rational zeros. All right, let's do another example. So these ones, there's a process behind these. And the process is just going to take some practice. So I want you guys to make sure you get some practice with these this week. So possible rational zeros, you've got a leading coefficient of 1, so you just want the factors of 24. So there's a lot of those. You've got 1, 2, 3, 4, 5 doesn't go in, 6, no 7, but 8 goes in, 9, no, 10, 11, 12, and then 24. Okay, put this in your calculator to find one of the zeros. How many zeros total am I going to have? 4. Good. Okay. So x to the 4th minus 6x squared plus 8x plus 24. All right, what's that zero? Yeah, -2. Looks like -2 checks out. Okay, so I have -2. I'm going to use synthetic division to go from 4th degree to 3rd degree. So I'm going to divide out this -2. Now, I am missing an x cubed here. So 4, 3, 2, 1. Okay, so 1, 0, -6 x squared, 8x, 24. So bring down the 1. 1 times -2, -2. 0 minus 2, -2. -2 times -2, +4. -6 plus 4, -2 again. -2, -2, +4. 8 plus 4, 12. 12 times -2, -24. So this gives us the function 1x cubed minus 2x squared minus 2x plus 12. So now I have a cubic function. So now what I'm going to do is I'm going to put the 3rd degree equation in my calculator, try and find another rational zero. So I'm going to put in here, go to y equals, so x cubed minus 2x squared minus 2x plus 12. Okay, then I'm going to hit graph. Okay, what's that zero? Look at my table. -2. I already found -2. Can I have it happen twice? I can, right? It's just a multiplicity. So that just means the factors x minus -2, so x plus 2, occurs twice. Okay, so that's a multiplicity. So if you get the same zero twice in a row, that's okay. It's just got a multiplicity there. So now I'm going to take this function here and divide out -2 again. So I've got a 1x cubed, -2x squared, -2x, and 12. So here I'm going to bring down the 1. 1 times -2, -2. -2 minus 2 gives me -4. -4 times -2, +8. -2 plus 8, 6. 6 times -2, -12. That gives me 0. So now I'm left with x squared minus 4x plus 6. Now I have a quadratic. Now I can use the quadratic formula. So we'll do -b, so -4. That'll turn into +4. Plus or minus b squared minus 4, our a is 1 and c is 6, over 2 times 1. All right, so this inside the radical is going to give me negative 4 squared positive 16 minus 24. So that's a negative 8. That's why I didn't see the graph crossing anywhere else, because I've got a negative under the radical. Okay, so I have 4 plus or minus root negative 8 over 2. So I'm going to take that negative and I'm going to put I in front of my radical. Then I'm going to continue simplifying the radical. So I've got 8 would break into 4 and 2. And then the square root of 4 is 2. So that's going to be 4 plus or minus 2i, sorry. 2i root 2 over 2. And then when you're reducing, you can't reduce these 2's in the radical, so you treat that one separately, but you could do 4 divided by 2 would be 2, and 2 divided by 2 would be 1. That would be 1. So then you've got 2 plus or minus 1i radical 2, so just I radical 2. And then your other 2 zeros are negative 2, and then with a multiplicity, 2. And then we've got our answers. And if we really, really wanted to check that, you could multiply the whole thing out, but we'll wait till pre-calc to do that. All right, so I want you guys, we probably won't finish all the practice problems, but work on these for just a few minutes here, and then we'll see what we can get through for the practice problems. Okay, let's go ahead and see if we can get through these. So for the first one, I'm going to go ahead and put this in my calculator. We're going to go x to the 4th plus 4x cubed minus 5x squared minus 16x plus 4. All right, so I've got a couple things here. That looks like it's not quite passing through, but I think here at negative 2 and positive 2, I've got one. Let's see. Negative 2, yep, and positive 2. So you can use either one. Typically, I go left to right, just easier. So negative 2, yeah, negative 2 would be the 0 I want to use there. If you use positive 2, that's fine. All right, so check your exponents. 4, 3, 2, 1. So you're going in descending order. You're okay there. And then the coefficients. So 1, 4, negative 5, negative 16, and 4. So we're going to do synthetic division. Bring down the 1. 1 times negative 2, negative 2. 4 minus 2, 2. 2 times negative 2, negative 4. Negative 5 minus 4, negative 9. This will be positive 18. Negative 16 plus 18, 2. 2 times negative 2, negative 4. These cancel, I get 0. So next function I'm looking at is a 1x cubed, 1 degree down, 2x squared minus 9x plus 2. Okay, so let's go ahead and put that in. Find another 0. So x cubed plus 2x squared minus 9x plus 2. Okay, and let's check here. I think positive 2, the other 0 we didn't use, should still be in play here. Positive 2, 0. So now we'll use the positive 2. Okay, and then our coefficients are 1, 2, negative 9, and 2. And here we will bring down a 1. 1 times 2 is 2. 2 plus 2 will give us 4. 4 times 2 8. Then we'll have -1, -2. These guys cancel. So now we have x squared plus 4x minus 1. And then we will use the quadratic formula to find the other two zeros. So we will go negative, let's see, -4 for b plus or minus 4 squared minus 4 times a, and c is -1 over 2a, so 2 times 1. So we'll have, let's see, 4 squared 16 minus 4 times 1 times -1, so -4. So that turns into 16 plus 4. I'm going to have a 20 under my radical. So -4 plus or minus root 20 over 2. And I want to simplify that root 20. I can pull a 4 and a 5 out. So square root of 4 there will be 2. So I'm getting -4 plus or minus 2 radical 5 over 2. And then finally I can reduce. So I'm going to have, let's see, 4 divided by 2 would be 2. 2 divided by 2, 1. So -2 plus or minus radical 5. So then my 4 zeros are going to be -2 plus or minus radical 5, and then also -2, positive 2. All right, and I think we have time for one more. So we'll start this one in the graphing calculator again. So let's see, x to the 4th. Number 1 was -2 plus or minus radical 5, and then -2, positive 2. All right, so let's take a look at this one. Looks like -1. Okay, -1 is a 0. Also, notice I'm touching and turning at -1, so that's probably going to be a multiplicity. Okay, so take the -1, multiply it out. Okay, so let's see. Check the exponents. We're going in descending order. We're okay. So we've got 1, -4, -4, 23, 62, and 34. Ooh, thank you for catching that. That would have messed us up. All right. Okay, so bring down the 1. 1 times -1, -1. -4 minus 1, -5. -5 times -1, +5. 23 plus 5, 28. 28 times -1, -28. 62 minus 28, 34. 34 times -1, -34. These cancel. So my next function is a 1, and you can do it here too. 1x to the 4th minus 5x cubed plus 28x squared. Sorry, cubed. Start with cubed. There we go. Okay. So 1x cubed minus 5x squared plus 28x plus 34. Put that in the calculator again. So x cubed minus 5x squared plus 28x plus 34. You've got -1 again. Check the table. Checks out. So divide out the -1 again. So this is going to be a 1, negative 5, 28, and 34. Okay, bring down the 1. 1 times negative 1, negative 1. Negative 5 times negative 5 minus 1, negative 6. Negative 6 times negative 1, positive 6. So give us a 34. Negative 34. These cancel out. All right, so now this is 1x squared minus 6x plus 34. So we'll plug this into the quadratic formula. So we'll have negative 6, positive 6, plus or minus. We're going to get negative 6 squared minus 4 times 1 times 34 over 2 times 1. So negative 6 squared is going to be 36 minus, 4 times 1 times 34 is going to be 136. 36 minus 136, negative 100. So 6 plus or minus root negative 100 over 2. What's the square root of negative 100? 10i. You just add an extra 0. I know what you meant. Okay, 10i. So make this an I. So 6 plus or minus 10i over 2. And then 6 divided by 2 is 3. 10 divided by 2 is 5. So 3 plus or minus 5i. So my answers for number 2, negative 1 with a multiplicity 2, and then 3 plus or minus 5i. All right, we're going to do something different with the last example. So